Welcome to my channel. Today, we're gonna try to prove the additive property of integrals. So basically, what this theorem states is that if you have some integral, right? Like say integral from a to b of f of x. Like f of x is any real functions, like anything, plus the integral of from a to b of g of, actually that parentheses was not necessary, so I can just erase it. There, let me fix it. There you go. Of g of x. G of x is also any real function, like any arbitrary real function. So this is equivalent to integral from a to b, the same bounds, but instead the function is gonna be f of x. Actually, I'm gonna put this in parentheses so it'll be clear that it includes the whole function, plus g of x. So this is the theorem we're gonna try to prove today. This is the additivity property of integrals. So without further ado, we may start. So assume that just a second. Assume that s of 1 and s, I mean t of 1, t sub 1, I mean, now assume that these two are like s sub 1 of x is any arbitrary functions below f of x, like this, corresponding, like this. So s sub 1 of x is any real step function. I forgot to mention that these are step functions. Step functions, s of f sub 1 of x is below function f of x. Same with this function. T sub 1 x is below is arbitrary step function below g of x for all x. So what we will try to do is prove that the lower integral of f of g equals the upper integral of f plus g, which equals to the integral of f plus the integral of g. So let me just erase this. Just a second. Almost done. Okay. So we know that the following is true. Like the integral of a to b of f of x equals supremum of all elements such that the integral from a to b of s sub 1 of x like such that s of 1 is less than or equal to f. So basically all this is saying is that the integral of f of x from a to b equals to the supremum of the maximum possible maximum possible function of s sub 1, because like if you have any function and you have any step function below it, the supremum of that function is gonna be uh, that same step function but the most maximum one. So with that in mind, we can also say that the integral from a to b of g of x equals supremum of all elements such that integral from a to b of t sub 1 such that t sub 1 is less than or equal to g. So this is the same idea as this, like same idea. But the only difference is that the corresponding step functions, because like s sub 1 corresponds to function f, and the step function t of 1 corresponds to function g. So, so far, so good. Now, what we can say now is we can add up and we can add up the integrals, integral of f and integral of g, to get the supremum of all sets. I'm sorry, this does not look like the brackets, not the brackets. Whatever it is, I forgot the name. So, supremum of the integrals of a to b of s sub 1 plus t of 1, this t, okay, I'm gonna make this t look more like a t rather than plus. Okay, this is better. So such that s sub 1 is less than or equal to f, and t sub 1 is less than or equal to g. So with this in mind, we'll need this later on. We may now use the theorem we're trying to prove for step functions, which we'll prove later on. So the theorem we're gonna use now is the same theorem we're trying to prove, but for step functions. So don't worry, I'll make a video proving the same like additivity property for step functions, but for now we're just gonna assume it's true. So assume that the, wait, I'm gonna erase this first. Just a second. There you go. This is so inconvenient. Just a second. Okay. So assume that the integral of s sub 1 plus the integral from a to b of t sub 1 equals integral of a to b of s. So we know that the s is also a step function because like s sub 1 and t sub 1 are both step functions. So step functions added to step functions are also step functions. So that integral of s is less than or equal to the integral from a to b of function f plus the function of g. This is true because like we said that s1 is below f and t sub 1 is below g. So this must be also true. This must also be true. That is true for all s, like all s possible. So combining the previous equations we did, like the previous equations we may now say that the integral of a to b plus the integral of a to b. Oh wait, I forgot to add the function. I'm sorry. That function is f plus the function of g is less than or equal to s of a b of f plus g. So this equation right here is true. Like, now you may ask, like, oh, but aren't you trying to prove that these two equations are equal? Why is it like it's greater than or less than? Less than or greater. I mean, less than or equal to. But actually, this is the first part we did. So like everything is going smoothly. Now we're gonna try to prove that. Since we proved this, now we're gonna try to prove that this is also true. So therefore, the only possible answer is gonna be the equal thing, equal sign. So, so this thing we did, like this inequality is true because like since we said that uh like the integral of a to b, I mean a to b of f plus integral of a to b of g equals the supremum of the integral of a to b of s sub 1 plus the integral of a to b of t sub 1 and this inequality too, like this thing. So we combined these two to get this right here. Like if you don't understand, like you can rewind to like review what equation I'm talking about. So this is the result we get. So with this in mind, we can go on. We can go on to talk more about it. So just a second. Almost done. There you go. So now what we may introduce now is new functions. So we have the same functions of f of x and g of x. Now, instead of s sub 1 and t sub 1, assume that there are like w sub 1 and a sub 1. These two are functions, by the way. I forgot to add x. That looks like y, but okay. And x. Now assume that w sub 1 of x corresponds to f of x by like a w sub 1 being the step function on top, like above f for all x, and a sub 1 is above g of x for all x's. So this is basically like the opposite of what we did for s sub 1 and t sub 1. So now with that in mind, we can also say that the yeah. Now with that in mind, we can also say that the integral of a to b from a to b plus w sub 1, I mean not plus, not plus. That cannot be plus, of w sub 1 plus integral of from a to b, that looks like q. Okay, we just know that it's a. So that equals to the infimum. Basically, that says like infimum is basically like the lowest function possible, like the bottomest element of some set. So infimum of integral from a to b of w1 plus integral from a to b of a sub 1. So since we said I forgot to mention, but w sub 1 and a sub 1 are arbitrary step functions. I mean, I said step functions, but I didn't say arbitrary. So yeah, they are arbitrary step functions. So we can say that the infimum of this equals to that, because like since this is the top above since w sub 1 is like above f of x and a sub 1 is above g of x, we can say that the infimum of these two function integrals added up equals to, oh wait, I messed up. Okay, I meant to say f and g. Yeah, my bad. I'm so sloppy. Like, I made so many mistakes so far. But moving on, uh these two step functions, infimum of these two step functions added to uh integral of f plus integral of g equals to this. So moving on, we may now use previous equations we did to say that the integral of f plus the integral of a to b of g is greater than or less than not the step function, the integral from a to b of f plus g. So with that in mind, this is true because we said that we said that this equals to this integral equals to this integral. So we can say that this inequality is true because this is true, and we also said that the infimum of the wait oh yeah so because of this inequality right here, this equality, we can say that this is true because like we used previous equations to prove that. So, but remember when I talked about when I proved that this was also true? Well, now I also proved that this is also true. So the thing is, uh, two same inequalities cannot both be greater and less at the same time. So the only possibility here is equal sign. Yeah. So therefore, we have proved that these two are equal. So the theorem is true therefore. So for the next video, I'm gonna upload like the same theorem is true for step functions, like when I talked about earlier about the step function, the same theorem being true for step functions. Yeah, I'm gonna prove that next time. And if you're still confused about this explanation, I'll still upload the LaTeX version, so like you can look over it as much time as you want. So thank you guys for watching. Uh, if you have any questions, please leave them down below in the comments. Please subscribe. We're trying to reach up until like 10K, so please consider subscribing. And that's it. See you until next time.